This is Mr. Mitchell, a physical science teacher at Coosa High School. I want to have a video about adding, subtracting, and multiplying and dividing in scientific notation. You may remember that scientific notation is an easier way to deal with very large or very small numbers, and it looks like these figures here. For example, this right here has a number times 10 to the exponent power, and the exponent is how far the decimal place has moved. So the question is, how do you add and subtract scientific notation? And we have another page for multiplying and dividing scientific notation. So why don't we give this a shot? I'm going to get my marker and get on the board right here. So the first rule is, well, it's the rule in adding and subtracting. The exponents must be equal. And by exponents, I mean the number that is out just above the times 10, just above the 10. And I decided to show these to you first because they do have equal exponents. This one is a 3 and this one is a 3. So this will show you how to do it, and then we'll try one that have different exponents and see what happens there. So it's very simple how you do this. You just add the two numbers that have the decimal right after the first number. So the 2.46 you will add to the 3.476, and that creates the first part of the scientifically notated numbers. And I've done this earlier, so I know that this has 5.536 is going to be what happens when you add these two together. But don't forget about these exponents here. And it's very simple whenever you add or subtract. You take the exponent that it started with, the common one, times 3, times 10 to the third. Now this particular one had the decimal. Once you added it, both of them, it had a decimal in the right place. You know the decimal is supposed to be just to the right of just one number. If these had been larger numbers, for example, a 9.46 instead of a 2.46, you would have had two numbers before the decimal, and you would have had to have changed that. But we'll see that in another one of these, and I will erase some stuff so we can try another one of these. Why don't we move this over here, and I will make it bigger. So let's try this one now. Now we have two exponents that are not the same. We have a 10 times 10 to the third and times 10 to the fifth. And you may remember that you have to have these exponents the same. You simply do. So what we will do is we will make this 5 a 3. And I guess you could have gone either way, but I've chosen to do that. So why don't we do this? We want to take the 5.25 and make it times 10 to the third. But the way you do that is to move the decimal. Now you may remember that if we move the decimal to the left, it makes the number bigger. If you move the decimal to the right, it makes the number smaller. So we want to make this number smaller to a 5, so we move the decimal to the right. If we go one place, it's 52.5 times 10 to the fourth, but let's go two places, and it is 525 times 10 to the third. So do you see what we did? We started out with 5.25 times 10 to the fifth, and we moved the decimal place twice. So by moving the decimal place twice, that makes 525 times 10 to the third. And that's what we wanted to do. We wanted to have equal exponents. And now we do the same thing we did before. We are just going to add what we have. We have 525 plus 7.5. So that will end up being a very manageable number. Add the 5, add the 2, carry the 1. So that will be 532.5 times 10 to the third. Remember, you put it at what it was. But we do kind of have a concern here. We have our final answer, but the decimal point is not in the correct place. Sure, this would work. You could understand what it is, but traditionally, you move the decimal point to where there is one number to the left of the decimal point. So whenever we move the decimal point over, we are going to the left. And when you go to the left, that makes the number bigger. So we are going 1, 2 places. So we're going to have 5 point something. We'll bring down the 3, 2, and the 5, just coming straight from here, times 10. Now remember, we started at 3, but we moved the decimal point 2 places to the left, so that makes this exponent bigger. So 3 plus the 2 places we moved it is going to be 10 to the 5th. So that happens to be the answer for that. And remember, that was in adding these. Now let's go to subtracting. The rules are the same for subtracting. So that makes it pretty easy. You want to have these two numbers, these two tens, have the same exponent. And in this case, they are. If they're not the same, just like with this one here, you do exactly the same thing you did here. You pick one of them and move it to the correct place to where you can have the equal exponents. But here it's pretty simple. You know it's going to be times 10 to the 5th, so you take this first number, 9.49, and then you subtract the second number. Subtract the 4.863. So once you subtract it, you will end up with 4 point something. Why don't I put that in my calculator? That is permissible to go with the calculator with this particular thing. So I'll go with the calculator and I will say 9.49 minus 4.863 equals, so I'm looking at 4.627. But keep in mind, you have to continue to have this exponent here. And like I said before, this makes it pretty easy because it is 10 to the 5th originally. And the decimal point is in the correct place. So that will help you there. Now you may notice that I have some practice problems at the bottom here at this tinyurl.com/y2u7d7h5. So you can go to that if you don't already have that worksheet. So why don't we take a look now at multiplication and division. Multiplying and dividing have different rules. We're not talking about the same rules you have in addition and subtraction. If you multiply the numbers. That's going to be the 3.2 and the 1.8, and then you add the exponents. Here we have an exponent of 2, and here we have an exponent of 4. You do not have to get them to the same number like you do in adding or subtracting, which kind of makes this a little bit easier because you don't have to convert anything until you get to the end. So I'll add the numbers. 3.2, oh, that is an awful looking 2, times 1.8. And whenever I put what that is, I will use my calculator. Times 1.8 equals, I see it is 5.76. So you got to add the times 10 and the exponent. And remember, with multiplying, you add the exponents. So it's simply 2 plus 4 equals 6. So that would be your answer here. Now keep in mind, if this decimal had not been in the correct place, you would have to then move it to the correct place, which would mean you would go down or up from here. In most cases, multiplying, you would probably go up because moving to the left means it goes up and moving to the right means it does not. It goes down. Let's take a look at dividing. Dividing numbers means you subtract the exponent. Now that's pretty simple. That's pretty simple. You multiply it, you add exponents. You divide it, you subtract exponents. So here you have two different exponents. You have 10 to the 6th and 10 to the 3rd, but you do not have to get them to the same exponent like you did in adding or subtracting. you are simply going to take the first number, 1.88, divided by, on your calculator, 2.0. And that's going to end up with 0.94. We're going to have to change this because the decimal does not have a real number on the other side of it. We'll have to move the decimal here in a little bit. But let's see what it is currently. So what you do, you subtract. Now be careful here. You have to subtract the number that's on the top of the fraction. My bad, let me say this correctly. You have to start the subtraction with the number at the top of the decimal and end the subtraction with the number that's at the bottom of the fraction, I should say. So you typed in 1.88 divided by 2. It's the same thing. 10 to the 6th divided by 10 to the 3rd is going to be the same as 10 minus 3. 10 minus 3, top minus the bottom. If this had been a smaller number than 3, for example 2, then it would have been a negative number because it's this number minus this number. So 6 minus 3 is 3. So it would be 0.94 times 10 to the 3rd. So how do you get this as it should be decimal-wise? You want to move the decimal here. And you may remember anytime you move the decimal to the left, to this way, you're going to end up adding numbers to this. It's going to go higher, but in this case you're moving it to the left. So if it goes to the left, it ends up getting smaller. Does that make sense? So we have 9.4 times 10 to the 2nd. Okay? So it goes smaller when you go to the left, the decimal goes to the left, and it goes bigger when the decimal goes to the right. Well, I hope this was clear, and you can see that we have some practice problems up here. Remember, with adding and subtracting, you are going to get the exponents the same. However, with multiplying and dividing, you don't. And with multiplying, you add the exponents, and with dividing, you subtract the exponents. Try the practice problems and see how it goes. Thank you very much.